In the vast tapestry of our galaxy, filled with frozen gas giants, barren, rocky worlds, an endless silence, there's one planet that refuses to play by the rules, K2-18B. It orbits a cold red dwarf, star over 110 light-years away in the Leo constellation. And yet, this alien world might just be the closest thing we've ever found to Earth and to life beyond it. For years, astronomers suspected something strange was happening there. First came signs of water vapor, then hints of carbon-based molecules. But now, with the James Webb Space Telescope scanning its atmosphere in unprecedented detail, we're seeing something that can no longer be explained by chemistry alone. What James Webb has uncovered has rocked the scientific world, the clearest biosignatures we've ever seen on an alien planet, gases that on Earth can only be produced by life. This is no longer speculation. This is data. And this is the moment we might finally admit we were never alone. K2-18B is what scientists call a High-Cean world, a hybrid between an oceanic planet and one with a hydrogen-rich atmosphere. It's larger than Earth, roughly 2.6 times its radius, and about 8.6 times its mass. But what truly makes it remarkable is that it sits right on the edge of the habitable zone of its star, the sweet spot where temperatures could allow liquid water to exist. The more we study this planet, the more it seems like a perfect host for alien biology. It's not a dry, rocky wasteland like Mars. It's not a scorching gas ball like Jupiter. This is a world likely covered in a massive global ocean, protected by a thick hydrogen atmosphere that keeps temperatures mild and shields it from radiation. The James Webb Telescope revealed that this planet's atmosphere not only contains water vapor, but also traces of carbon dioxide and methane, crucial ingredients for organic life. These gases, when found together in a hydrogen-rich world, begin to draw a picture that's hard to ignore, one where biological processes may be at work beneath the waves. But then came the real shock. In 2025, new data from Webb's MIRI instrument, the mid-infrared spectrometer, found not just carbon-bearing, molecules, but something far rarer, dimethyl sulfide DMs. On Earth, this compound is almost exclusively produced by living organisms, specifically marine phytoplankton. The presence of DMs in a planet's atmosphere would be like stumbling on a trail of oxygen on Mars. It's not just chemistry anymore. It's biology knocking on the door. But that wasn't all. The same study detected dimethyl disulfide DMDs, a more complex compound also tied to microbial activity in Earth's oceans. The fact that these molecules appeared together in an environment rich in water vapor and carbon compounds has led scientists like Cambridge astrophysicist Niku Madhusudan to suggest that K2-18B may be teeming with microscopic alien life. These aren't speculative headlines. These are molecular signatures, consistent, verified, and statistically significant enough that the scientific community is now seriously considering a world beyond Earth, where the oceans might be alive. So, what kind of life could exist on K2-18B? If the dimethyl sulfide is truly being produced by living organisms, scientists believe the most plausible explanation is that K2-18B's oceans are home to phytoplankton-like life, tiny floating microorganisms that may use the faint red light from their cool sun to carry out a form of photosynthesis. But others suggest a more complex scenario. Some theorists envision filter-feeding creatures, not unlike Earth's earliest multicellular life, drifting through nutrient-rich waters, absorbing organic matter, and leaving behind chemical trails. Some even go as far as to imagine alien analogs, two flying fish organisms that evolved in low-gravity, high-pressure environments, possibly capable of limited atmospheric movement. In essence, K2-18B may resemble Earth, not as it is now, but as it was 3 or 4 billion years ago when life was just beginning to bloom in its oceans. And just as Earth's early biosphere transformed its atmosphere over time, the same could be happening there. we're witnessing it in real time. And now, as the evidence mounts, a new debate has emerged. K2-18B is home to life. Should we try to communicate? Some voices in the scientific community say absolutely not. Physicist Mark Buchanan warns that actively reaching out to an unknown biosphere could risk exposing Earth to a civilization we're not ready to face or endanger a fragile ecosystem with our interference. Ethical philosopher Dr. Anthony Milligan argues that we have a moral obligation to tread carefully, not only for our safety, but for the protection of whatever may exist out there. Others, like Avi Loeb, believe that any intelligent life advanced enough to detect our signals would have already noticed us and might not even take us seriously. Regardless of where you stand, the truth remains. A signal from Earth would take 120 years to reach K2-18B, and another 120 to get back. For now, we wait. But the data keeps coming. The molecules are there. The ocean is likely real. And the idea that we're alone in the universe is fading fast, with K2-18B now in the spotlight. The world's leading space agencies and private space companies are quietly shifting priorities. While no current propulsion technology can get us to this ocean world in under several centuries, discussions are already underway to launch the next phase of observation. A fleet of next-generation telescopes that can monitor it continuously and in higher detail. NASA is preparing to accelerate the development of the Lavoie and Habex observatories, both designed specifically to identify life-bearing exoplanets by analyzing atmospheric chemistry. Meanwhile, the European Space Agency and even China's CNSA are proposing their own deep space exoplanet monitors. But it doesn't stop there. The idea of launching an interstellar probe, possibly using laser propulsion and solar sails, is gaining traction. The Breakthrough Starshot initiative, backed by billionaires and scientists alike, proposes sending microscopic probes at 20% the speed of light. If successful, such missions could reach K2-18 billion in 500 years, a timeline long for us, but short in the cosmic scale. Humanity may never walk its shores, but we may witness, for the first time, a message sent from Earth to life beyond. The scientific implications of finding possible biosignatures on K2-18B are monumental, but the cultural impact may be even greater. Across the world, religious leaders, spiritual thinkers, and philosophers have begun offering interpretations of what this discovery means. Some call it proof that life is not unique to Earth, but part of a grander cosmic design, a universe wired for consciousness, not silence. Others have expressed fear, discomfort, and even denial, warning that our worldview isn't ready to confront such a revelation. Social media has exploded with hashtags like #K2Alive and #OceanWorld. While documentaries and fictional adaptations are already in production, governments remain cautious in their official statements, balancing excitement with scientific rigor. But beneath the surface, a subtle shift is taking place. The collective realization that we are no longer just explorers. We are being watched back. And in that realization, humanity is experiencing something rare. Global unity. Not in fear, but in awe, as the momentum builds to uncover more about K2-18B. A growing chorus of voices warns of the need for planetary protection. Ethics, not for Earth, but for the alien biosphere. International panels are now convening to propose a new category of protected worlds, exobiological sanctuaries. These would be exoplanets like K2-18B, where signs of life have been detected and which must be studied only from a distance to avoid contamination. Astrobiologist Dr. Monica Vidari insists that if K2-18B truly harbors life, it has evolved for billions of years without us, and we have no right to interfere. Proposals have emerged calling for a kind of interstellar no-fly zone, placing limitations on future probe trajectories and emissions. These discussions reflect a deeper understanding. Just because we can observe doesn't mean we should invade. Because even if those oceans are silent now, even if that life is microbial, it is still the first confirmed kin we've ever found in the vast universe. And if we are wise, we'll learn to listen before we act. Perhaps the most profound aspect of K2-18B is not what it tells us about aliens, but what it reflects about ourselves. Here's a planet that may host oceans, clouds, and perhaps even primitive organisms, just as Earth once did, long before humanity ever walked its surface. In a way, observing K2-18B is like looking backward in time at our own origins. It reminds us of how fragile life is, how rare the right conditions must be, and how precious our own blue world truly is. Some scientists believe K2-18B could help us understand how life begins, adapts, and possibly evolves elsewhere, offering clues to protect our own biosphere from collapse. Others say this is a turning point, a moment when science, faith, and wonder finally converge on one truth: that life is not the exception, but the expectation. In the cold, quiet depths of space, we may have found not a stranger, but a reflection of what we once were and what we still might become. K2-18B is no longer just a distant blip in the cosmos. It's no longer just a number in a telescope's database or a cold dot on a star chart. It is now a window into another possibility, a place that, against all odds, whispers the same chemical secrets as our own living planet. And in that whisper, something has shifted. For decades, we asked the same question: are we alone? But now, with the James Webb Telescope revealing the unmistakable signs of water, methane, carbon dioxide, and possibly even the molecular echoes of alien life, the question has changed, because we are no longer standing at the edge of belief. We're standing at the edge of confirmation. K2-18B may be the first. It may be the closest, but it will not be the last. There are thousands of worlds like it, waiting to be seen, studied, understood. And as we stare across the darkness at this one watery giant, we are not just discovering the universe, we're discovering ourselves. So now we ask you, do you believe K2-18B is home to life? Should we send a message, or should we remain silent? Observers, and if this really is the moment we prove we're not alone, what will humanity become next? Tell us what you think in the comments. And if this journey across the stars moved you as much as it moved us, subscribe to the channel. Turn on notifications. I'm going to share this video with someone who still looks up at the night sky and wonders. Because the universe may be vast, but tonight it feels a little smaller and a lot more alive.